welcome back to the South Dakota School of Mines and Technology Thermodynamics homework solutions. This is homework 9, this is problem number 4. We are doing other vapor and liquid equilibrium, or rather other equilibrium. And in this context, we are doing liquid equilibrium. So we're doing a problem from Koretsky is 8.73. Now how do I know it's liquid equilibrium? Well, I think it really says pretty much. Let's see here, 8.73. So, it says, tetrahydrofluorine and water separate into two liquid phases. Two liquid phases means liquid equilibrium. Okay, and so, again, with any problem, I write down what I know, my equations. So, x I in the alpha phase, gamma I in the alpha phase equals x I in the beta phase and gamma I in the beta phase. Okay, and that's for each component. The other thing is that the summation of xi in the alpha phase has to equal 1. The summation of xi in the beta phase has to equal 1. Okay. Okay, so it says I know T and P. Okay, I need to find the composition of each liquid phase. Okay. So I have 4 equations, but I have 4 unknowns, so I know enough to solve this problem. Let's erase that. Oh, that's a beta. Okay, so I know enough to solve this problem. Okay, so I want to say that, x1 alpha is equal to, or rather, x2 alpha is equal to 1 minus x1 alpha, and x2 beta is equal to 1 minus x1 beta. I plug those into my model. Now in this case it's 3 suffix Margulis, but it doesn't really matter what model it is. Hey, let's treat this as if it was 2 suffix Margulis. Now it says 3 suffix, and I'll let you do the math on 3 suffix if you want to see how the math works. One of the examples actually uses 3 suffix, but let's use 2 suffix so that we know that RT natural log of gamma 1 is equal to ax2 squared, RT natural log of gamma 2 is equal to ax1 squared. Now you might be like, well, is there a different a between alpha and beta? There's not. I use the same alpha and beta, but just the way the physics work, I'm going to have a different gammas, so to speak, based on the different compositions that happen between these. Okay, and so when I kind of quote unquote, so I've got those equations, okay, and then I got this equation, so I have x1 alpha is equal to, let's see here, we'll call a over RT equal to a prime for ease. So I've got x1 alpha exponential of let's see here, a prime 1 minus x1 alpha quantity squared is equal to x1 beta times exponential of a prime 1 minus x1 alpha quantity squared. Okay, so there's one equation. But I have 2 unknowns. I have an x1 alpha and an x1 beta. Okay. Then I have the other one. I have 1 minus x1 alpha times exponential of a prime x1 alpha squared equals 1 minus x1 beta exponential of a prime 1 x1 beta squared. Okay. So I have 2 equations, 2 unknowns. Now, can I solve this algebraically? No. Could I solve this algorithmically? There's really not a good algorithm for this. It'd probably be better to use something like Solver, but let's say it was going to solve this algorithmically. I would ask my questions. What do I know, what do I don't know, and what do I have values for? Okay, and so, well, I know basically T and P. Alright, that kind of helps. That allows me to get A, but I don't really know X in any context. And so maybe what I'm going to do is just say, hey, let's just assume that x1 yeah, I'm thinking if you're going to do this algorithmically, you might want to assume that both are 50%, because they're going to be between 0 and 1. What you'd want to do is you'd want to use one to feed into the other. What do I mean by that? I'm thinking, now I don't quote me on this, I don't know if this does exactly work. I would probably use solver or something, or a graphical solution to start with. But my thinking is, okay, you get 50%, okay, and that's going to give you a certain answer. So you plug in the 50% for this guy, for this guy, and for this guy. Which will automatically make that one 50%. Shoot. Alright, scratch that idea. Okay. Let's make one pure, and let's make the other one infinitely dilute. Okay, so what if I did that? Now that will give me a different answer. Okay, so if I said that x1 alpha is equal to 1, x1 beta is equal to 0, okay, that will make this one exponential a times 0, which is, well, yeah, not times 0. See, I want to solve for the x1 beta, so I would use this to solve for this x1 beta, so that x1 beta was equal to x1 alpha exponential of a prime, x2 alpha. And again, these are 1, so this would go up to 1. Okay, this would go to 1, and then I'd be dividing by exponential of just a prime. Okay, and that would give me an x1 beta. I use that x1 beta to feed into here, using the same x1 alpha, which is in this case 1, to figure out this x1 alpha, and keep cycling that back in. That would give me a new x1 alpha here. I could cycle that one back here, but now I have a good value of x1 alpha and x1 beta, and then I could cycle through these two. But essentially, I just need to set up the equations and solve for them.